Alright, hey guys, this is Mr. Church. Obviously I'm not in class today, so I'm having to make a video instead again. I apologize for that, but it's the best I can do without being there at school with you. So what I have here is some notes from yesterday. Now I know some of you already have these notes, and some of you will not need to write these down. However, I can't remember quite which classes were able to get these notes and which ones were not. I'm pretty sure this applies mostly to first block and second block. So if you're watching this and you're like, well, I've already got these notes, just scrub through the video real quick, make sure you have everything you need, and I'll show you the end result over here. I'll go ahead and do that. So you'll see I have some blank spaces down here in this area to fill in, but if you're looking at your notes from yesterday and you remember figuring out the perimeters and areas of these two rectangles in our last example, then you're probably good to go with these notes. I'm going to go back now to the beginning, and for those who have been out, it's a good opportunity for you to get these notes. I've set this up in a very similar way with the title up here at the top, today's date, and of course Q questions over here on the side, and don't forget also at the bottom we have a summary. So keep that in mind. For I think a lot of us, though, we already have this first part down, and central question, and we actually already talked about the definition of similar figures. So it's two figures that are the same shape, not necessarily the same size. So they can be the same size, but they may not be. Okay. The key parts of this were that corresponding angles are congruent, and corresponding sides make equal ratios, and that's this part right here. Very, very important. That is the core part of this entire lesson. If you understand that, then you'll be pretty good to go. Now, if I'm moving too fast for those who need to get these notes, feel free to pause the video, rewind it, whatever you need to do, but I do expect you to have these notes down and completed. And when I return on Monday, I expect you to already have these and not be asking for them then. Okay, so I'm going to move on down here. And again, pause the video as you need to stop it. Our example here that I'm using for similar figures will be these two triangles. We have this triangle over here, and then we've got another triangle over here that's a little bit smaller. Now notice they are two different sizes. Well, that didn't work out very well, did it? They are different sizes, but they are the same shape. Okay, so again, the key parts will be that if they're similar, corresponding angles are congruent, and corresponding sides make equal ratios. So we're going to start with the angles down here, and we're going to actually match up angles that correspond and kind of eyeball it, just kind of make a visual observation about whether they actually look congruent or not. So first I'm going to start with angle A, and I want you to take a look over here at the small triangle. Which angle seems to correspond to A? Well, that'll be angle D. So down here under angles, I'm going to write angle A is congruent to angle D. Okay. Likewise, if we take a look at angle B here, over here in the small triangle, angle E corresponds to that. So I'm going to write under angles, angle B is congruent to angle E. And then lastly, we have angle C, and it is congruent to angle F because they correspond to each other. So angle C is congruent to angle F. And that's just like the same list we made for congruent figures. Over here at sides now, it's not that the sides are equal. It's pretty obvious these sides are not equal. They're two different triangles. But the corresponding sides make equal ratios. So if we take a close look here at, let's see, pick a good color, side AB right here. Okay, that side, it corresponds to side DE right here. So I can make a ratio of those two. And in 7th grade, you learned how to make ratios. So we can write it like this: side AB, that ratio, the ratio of AB to DE, that ratio, notice I've written it as a fraction, should be equal to two other ratios. Okay, and the reason I say two more is because I have two more sets of sides that I can use. Okay, so if I take a look now at side BC right here, it corresponds to side EF. So that'll be my next ratio. The side AB to DE should be, that ratio should be equal to side BC to EF. And lastly, we have side AC or CA, however you want to describe it. So we'll say AC. That is the ratio of AC to DF will make an equal ratio with the other two. So we have AC on top and then DF down here. All right, so all three of these ratios, 1, 2, 3, have to be the same. If not, then the figures are not similar. Now, again, if you need me to go slower, just pause the video so you can copy it down, go back, write it down again. But again, the expectation is that you have this done by Monday. On the next page here, I had to go to another page for this. This is really where the 8th grade stuff picks up. We're talking about perimeter and area of similar figures. And I have an example here with 2 rectangles. So again, pause the video if you need to, and we're going to go through this very quickly. So the goal here with some of these problems is going to be to find a missing side. And if you look right here in this example, we have 6, we have 10 in rectangle A, and then we have 3, but here we have X. Okay, so this side right here is the one that we're going to have to find. All right, so to do that, we use something we learned in 7th grade, and that is how to write a proportion. Now, remember, if these two rectangles, rectangle A, rectangle B, if they're similar, then their corresponding sides make equal ratios. So if you'll take a look, I purposely wrote 6 and 3 in the same color because they're corresponding sides. So if we make a ratio, we'll have 6 over 3. That ratio should be equal to the ratio of 10 over X because 10 and X are corresponding. Now, it's no mystery here. I think most of us can probably go ahead and tell what X is without doing this, but the idea, of course, was to make an example or use an example that reminds us of what we did in 7th grade without being too difficult. So to solve a proportion, if you remember, we actually cross multiply. So what we'll do is we can do something like 6 times X and then 3 times 10. And 6 times X is 6X and 3 times 10 is 30. And to solve this equation, we would just divide by 6 on both sides. You should know how to do this already. Of course, we get X equals 5, and there's our answer. All right, again, that is a 7th grade skill. Now that we know that, I'm going to write 5 up here. Let me write that in green so it matches our 10. All right, so if X is 5, that means this side down here also has to be 5. This side has to be 10. And then this side has to be 6. And this side over here has to be 3. That's important because down here, we're going to actually compute the perimeter and area of each one of these rectangles. And that's where the 8th grade material really comes in, is when we have similar figures, how do the perimeters of these figures and the areas of these figures actually compare? Are they the same? Are they so many times larger or smaller? So we're going to start by finding the perimeter of rectangle A. And remember, to find perimeter, we simply add up all the sides. So we have a lot going on here. Let me erase some of this so we can concentrate on what's important here. Too many arrows and other stuff going on. I'll go ahead and get rid of X, and I'll move that 5 down to there. Okay. So if we look at rectangle A, we have 6, 6, 10, and 10. And again, I'm looking right over here at rectangle A. We have 6, 6, 10, and 10. So down here for the perimeter on A, I'm going to write this as, I like to add the 10s first. I'm going to do 10 plus 10 plus 6 plus 6. And that'll give me 20 plus 12, which is 32. So 32 units. We don't know if it's inches, centimeters, or whatever, so we're going to say units. All right, that's the perimeter for A. For B up here, we have a 5, 5, 3, and a 3. So I'm going to do something very similar. I'm going to go ahead and add the 5s first. It really does not matter what order you write this in or add it in, as long as you add it. So 5 plus 5 is 10, 3 plus 3 is 6, and we get 16 units. So if you compare these two, We have 32 units here, 16 units here. It's obvious that this one is 2 times larger than the perimeter of B. Let's look at the areas now. And again, I'm moving pretty quickly. Pause the video, go back if you need to. I just have a time limit on here of how long I can actually record in one video. So for area, if you don't remember, the area of a rectangle is length times width. And sorry about that. In seventh grade, we use length times width. In 8th grade, we use base times height. So if you look back up here at rectangle A, the base is 10 and the height is 6. So nothing too difficult here. We're going to do 10 times 6, and that gives me 60 square units. And we can write that like this, 60 square units. The area for rectangle B, if we do base times height, will be our base is 5 and our height is 3. So down here I'm going to use the formula again, base times height equals 5 times 3, and that gives me 15 square units. Now, you were probably predicting, if you were thinking ahead, that the area for this rectangle was going to be half the area of this one, because up here the perimeter right here was 16, and that's half of 32. However, if you'll notice here, 60 is actually 4 times the area of the perimeter over here for the small one. So the point here is that perimeter and area are affected in different ways, but we can't compare the areas until we find them. We can't compare the perimeters until we find them. All right. So again, if you need to pause the video, feel free to pause it at any time. Go back and rewatch it if you need to. Again, the expectation is that you have all these notes completed basically before you leave class today, and you're prepared to use them on Monday. All right. Thanks for watching.